Thanks, everybody. So, as he said, I'm Patrick.
Owen, Snide.
I work for Radware as a security architect doing large-scale DDoS mitigation, web application firewall, and load balancing stuff. But I have a background in telephony, used to manage product security for a SIP security company.
So I'm pretty much just a random guy who work for a financial institution. I do AppSec stuff, or did AppSec stuff. I kind of moved roles, but that's what it is. I have no real experience in VoIP, as it were. So,
which makes this a Wonder Twin.
Yeah, it's a weird combination.
All right, so standard disclaimer, these are our views and don't represent anybody else, and sorry if we stole your photos and clip art.
Yeah, so why are we doing this? Like, how do we come up with this? I just randomly came up one day and was like, hey, we could do a presentation together. So.
Yeah, and I really wanted to do this because you know, I started meeting a lot of or some freakers at DEF CON and stuff, and doing some reading, and you come to realize that, you know, they were the original electronics hackers, I guess, in the modern age anyways. And, you know, before we had all the stuff we had today, really the phone system was the only thing that we could play around with and hack on. People didn't have personal computers. So it's important, I think, to know what your legacy is, what the history is, and certainly the types of things and the mental approach that they used in phreaking really is still used today. So we see things like, you know, new systems that are developed, like VoIP. The first iteration wasn't really designed for security. So
well, none of it was, right? It's kind of like the internet is just like building upon stuff, but not necessarily taking security into mind. So.
Right. So that proves, I guess, the title of the talk: what goes around comes back around.
And what we're covering this is just a little bit of history, attacking and defending voice systems. There'll be cats, dogs, pictures, and tips and tricks of Asterisk. It's a PBX of choice. So before we change real quick, this might be useful to like small companies. This isn't going to be like your enterprise level, I spent so much money on my phone system. This is more going to be, what, small, medium-sized businesses that happen to be running appliances, running Asterisk, or something someone set up.
Though a lot of the security tips at the end and stuff are
common sense, right?
Yeah. So we're going to publish everything on GitHub, and the GitHub actually has a reference sheet on it that I actually sent to a VoIP security engineer yesterday for proofread, and she loved it. She printed it out and put it up in the office.
That's
so
cool.
I thought that was pretty nice. All right, so telephony history. You know, the first real human long-distance communication, electronic communication, was telegraph. And the telegraphs were all point-to-point. So individuals on each end with the actual little telegraph doohickey.
Kind of like your can with a string in it, right?
Exactly like that, yeah. And every connection had to be run, you know, point-to-point. You couldn't, there was no magic thing in the middle that would switch so you could talk to different people. It was one-to-one. And the same thing happened with the original phones that came out. You could actually, if you were rich, go and get a phone for your office and a phone for your house and maybe a phone for somewhere else. But by the way, you had to put a second phone beside the one you already had. It was point to point. That was it. And they also charged people for running the wires. So if you wanted that and it was 2 miles away, you had to pay by the foot for the wire. And, oh yeah, by the way, you just paid for that, but you don't own it. The telephone company owns everything.
There was just a different world.
Totally, yeah. And there was no dialing involved. You would pick it up, and you still had to talk to an operator and say, or sorry, when it stopped being peer-to-peer, and they started putting these little operators in, so you could talk to different people who also had phones. It was all pick up the phone, tell them who you want to call, and they'd make the manual connection. And of course, this starts to catch on, more switchboards, more people, more wires, it gets crazy. So they start trying to figure out what they can do to simplify it a little bit.
Because obviously that didn't scale too well when they tried to
Not
figure
at
it
all,
out.
not at all. So Interesting story, a guy named Al Stroger, and if you're a longtime CarolinaCon guy, you might know this Al Stroger, different guy. He was an undertaker.
But Al also is an undertaker. So.
He was wearing black, right?
Yeah.
So Al Stroger was an undertaker, and he found that his business suddenly took a nosedive. And he was trying to figure out what the reason was. So he ended up calling his own number and telling the operator he wanted to be connected to, his office. And all of a sudden he got connected to somebody else. Turns out there was another undertaker in town who was stealing business from him because the guy's wife was the operator in town. So she would start diverting calls. So he was ticked off about that and decided that he was going to come up with something that would take operators out of the loop.
As you do, right, in that situation.
Yeah, so he came up with this Stroger switch, and if you used like some of the old rotary dials and you would hear the click, 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 that was actually an electronic pulse being sent down the line, so that the switch on the other side could actually increment. It was like a barrel shape, and it would actually turn, and there was a little metallic connection that would actually go across the barrel. They had 3 buttons, and you would dial the hundreds place, the tens place, and the ones place separately, and you had to push that however many times you wanted the pulse to happen.
Sounds complicated.
Very complicated. So fast forward, and they introduced rotary dial phones. In order for one user to reach another, they had to have a way of representing what the dialing of the day was before the user could dial. So what you would do when you called somebody before a user dialing was you would pick up the phone and say, I want to talk to Wake Forest Road 137. That was the exchange that you wanted to be connected to, and then the user or subscriber number. So those letters that you see on the modern touchtone phones today, that was their way of representing the exchange numbers numerically, or the exchange locations numerically. So Wake Forest would resolve to 2 numbers, and then the user extension. So the problem with the system was it didn't offer long distance dialing. So you still had a lot of operators, and operator workforce was growing and growing as more phones were deployed. So AT&T recognized that they had to come up with a longer term solution because they literally were looking at 1 million employees by maybe the mid-60s. Or I should say that's what they were going to have to hire. So they
That's
built
a lot of people answering phones.
They built this thing called panel and crossbar, and it introduced common control. So basically, when you dialed a number, it would build up that number in something called the sender, and then the sender would forward on the dialed numbers to the switch.
It kind of stores it in memory and then sends it.
Right, exactly. Oh, and I should have mentioned that was the problem with the Stroger switch. When you dialed and it made that connection for you, it held that switch for the entire duration of the call, so nobody else could use it. Yeah, it tied it up. So that allowed them to start, conserving some resources, I guess. And but the problem was still making routes from city to city was difficult. You still had to talk to operators, and maybe multiple operators, because they had to like call one another all the way through and do all this plugging and stuff. So the 4A crossbar introduced something called card control. So it was a metallic card like the old school punch cards, and it had little holes in it that would indicate the path from your location or your switch that you were connected to a foreign exchange, and it would say, these are the hops you need to take. Oh, if it fails, this is an alternate way to get there. Okay, pop quiz. Single frequency and multi-frequency were 2 different systems. Single frequency came first, and then multi-frequency. What tone was critical in signaling? 2600. Exactly. And what was the design flaw that revolutionized the industry and put us where we are today? Exactly. Man, this is too easy. Yeah. I got a bunch of freaks in here, don't I? So, freaking was around for a really long time, but the first awakening, I guess, for the general public was in 1971 in this article called Secrets of the Little Blue Box. And the author spent an awful long time interviewing freaks, getting to know them, and introduced the world to guys such as Joe Ingressia, a blind freaker who went by the name of, or the handle of Joey Bubbles towards the end, Mark Bernay, John Draper, aka Captain Crunch. These guys were not the first freakers, and many people, myself included, when I first started getting involved in VoIP, I always heard the Captain Crunch whistle tale, and well, that's where it started, right? No, it happened way before that. As early as phones were around and they started using this type of signaling,
yeah, people exploring it,
yeah,
and seeing
people
what they
started
could do.
exploring it and dialing all
Curious,
kinds
right?
of crazy numbers, and hey, where can I call? So a lot of people were doing it, and those of us who were more enthused about technology started like listening to the tones and hey, I wonder if I can recreate that. So they used audio tape and eventually used tone generators and things like that. And one of the sort of interesting cases was actually in 59, 60 time frame. These three guys between Harvard and MIT, again, like everybody else, they were playing around with magnetic tapes first. Guy from MIT says, I can build a tone generator for that. And they made a lot of calls. Well, they happened to call an Air Force base, and that's when the FBI got involved, and you know they were grilled, and you know AT&T wanted them prosecuted. They thought maybe they were aspiring or something. You know, why are they calling an Air Force base? Long story short, there were no laws against any of this, and while they were sternly warned and some of their equipment was taken away, couldn't do anything about it.
You know, that could have gone real bad if you hadn't
yeah, they would have been in a box for a long time.
Air Force base these days, you could have some serious consequences.
So there's some fun stuff that you know, many freakers would set up, like a joke line or you know something interesting to hook up to the phone system, but that was technically a terms of service violation, and because of the legal protections offered to AT&T, the sort of the national phone system that was privately owned. Anybody know why? Why was it not allowed to hook up something of your own?
You could damage their network, right?
Yeah, you could damage their fragile network, and one would wonder, like, if it's that fragile, then maybe they should have engineered it differently. And it wasn't fragile, as was proven repeatedly. So that's kind of it for my brain dump on history, but Exploding the Phone by Phil Lapsley, if you're interested in any of this, is an awesome read. So eventually, freaking got shut down, and really the thing that stopped that was common channel interoffice signaling. They said, we have a problem, how are we going to fix this? They took the signaling, instead of being in band so you could actually hear it, they made it go on, basically over modems on a separate channel between the two exchanges that were involved in setting up calls. So no more funny little tones in that. Personal computers came out eventually, and a lot of these freakers got involved in personal computing because, you know, it was the next thing and it wasn't illegal, so they could do it without getting...
It's kind of new, right?
Yeah. So everybody got computer terminals and, you know, BBS, and then the internet was developed. So, you know, freaking was illegal. You could get caught. Most of it wasn't working anymore anyway, so everybody turned into hackers, computer hackers.
Oh.
Right. So then you have the internet and IP, and you can start cramming things into it. And this is part of the subject of my talk last year. You know, you can start cramming SIP over IP. Analog systems were still around, and people wanted to keep some of their investment. So the manufacturers ended up developing cards that you could cram in the back of many of these to convert the IP voice over to analog, so you can still use the old phones. And then as things evolved, of course, everything's going towards software. So now we have completely IP software, PBXs, soft clients, so you don't even need a handset anymore. And of course, now virtualization, any one of us can set this up.
So what does the future of VoIP have in store? I mean, who knows what Justin Timberlake's going to do, so we don't know. But you have some thoughts or insights for WebRTC?
Yeah, I mean,
towards the web.
WebRTC is the buzzword right
It's the
now.
future.
It's an API so that voice is opened up to web developers.
So that's what we need, is our voice running through a web browser.
Yeah, exactly. And you know, HTML5's WebSockets and all that garbage. So you know, there's no set signaling method. So it's a whole new
So
frontier.
we're going to move to, I guess, over web, right?
Yeah.
Let's see. That's who he is.
All right.
Car, right?
So you're not getting a brand new car today. We're not showing any elite
It's right under your
exploits. We're going to
seats.
show some really cool stuff, mostly what he did. But yeah, we're just going to give you some of the things that are possible. Yes, there are SIP attacks and things that I'm not going to cover. And don't come up to me later and go, well, you missed that. No, I'm not going to cover everything. It's just too much.
All right, so how many people have heard of Asterisk? Well, let's see. We got two, quite
Awesome.
a few people. So,
Awesome.
so you guys will know a little bit about it. It's made in '99 by a guy called Mark Spencer from Digium, and it's GPL. It's really pretty cool stuff. You've got ARI and AMI, which are RESTful interface and management interface for it. So you can kind of extend when you get a phone call and do some really cool stuff. Now the AGI is like the CGI of phone systems. So what you do is you get a call and you can process based on that, like by your voice or if you dial the numbers. So I had an extension that I would, when my power goes out, I would dial my home phone because it comes back. When the power comes on, it will read me my IP address. You can do some cool stuff like that. So that's rather neat. So when Asterisk kind of evolved over a period of a bunch of years, you have a bunch of variants now. So we had discussions of which was the box, and we figured out that I guess the distributions are the box in this case, but FreePBX, Asterisk, all of those, they all kind of try and wrap a bunch of software into a package that will run. But
So you a buggy OS with Asterisk,
Right.
and then I'm going to cram my own possibly messed up web browsing interface on it.
yeah, and what you end up with, if you have anyone who's, I guess some of you have at least seen Idiocracy, where they just keep on piling garbage up and it all just like falls and busts up his lawyer's apartment. That's kind of where we are. It's going to fall over or something. So,
All right, so now we're going to take you through several different areas, and for each we're going to cover red team, what the red team should or could do, and then what you
On the
can do to
defensive side,
defend,
right?
right? All right, so information leakage, systems designed to be used by authorized parties, reveals usage equipment, basically cool stuff I can use to hack it later.
how did the freaks do it?
Yeah, so the freaks, the very first freaks, because dialing was pick up the phone and talk to somebody to make that happen, they had to use social engineering. So
Before it existed as a term.
Well,
They
yeah,
had to
exactly.
talk to people.
I was just told this morning it's kind of busted, but
They have
it's
to talk to
not a
people.
term I should be using. Anyways, so they would pretend to be phone techs. You know, this is test board 103, and I need you to connect this call just to test the lines out. Or they would actually, believe it or not, these hackers had girlfriends. So they would get their girlfriends to make the call for them and then take the phone and, you know, continue their social engineering. And of course, there was only one phone system. So I said AT&T before, but yeah, it was technically Bell before. Bell was, you know, they had no reason, I guess, in their mind why they couldn't share this information on how awesome their network was. So they printed up these technical journals where they literally laid out how things were engineered, and that's how the first guys to build blue boxes.
I thought that was kind of cool. It's kind of like open source. Here's how. Here's how to
Exactly.
use it. Here's how to do
Open
what you
source
need.
is good and bad.
I think very quickly there's some dumpster diving behind some AT&T.
Not at all, not at all. The 1960 Bell Technical Journal had an article that laid out the exact frequencies for every single tone that they generated. And it was like, took one hacker to go in and read it and go, wait a minute, I can build a box that can generate those tones. And he developed the first blue box.
So now, how do you get information leaking
Yes.
out of a phone system?
Now, I mean, you can get a VM at home and play around with it, scan the interwebs and find IPs, port scanning,
Showdown or whatever.
yeah, SIP stack and OS fingerprinting, extension enumeration, where you just like send an invite, basically a SIP call request to every single extension number possible, 1000, 1001, 1002, and then see what responds.
Well, you can go to the website and just see what you can find, right?
Exactly, like what's their HR number on the website, and oh, okay, that's what their extension range might be. So from a red team perspective, you know, there's all sorts of passive things you can do. Of course, Google searches, Shodan, And I've got some samples there, you know.
The register and invite.
Yeah, now I know exactly what types of exploits I might need to go look for. Bam, just like any web scanning stuff too. The VoIP signaling itself is clear text, and I've got a slide that'll show that. So you can actually give away information about your environment unwittingly. If you're internet connected, you just a quick options or invite message. There's SIP methods, and the system will respond back and go, here's what I'm running. So this is what SIP looks like, and of course in red there's some things that will tell you maybe what you're actually talking to.
If you notice, it looks a lot like HTTP.
Exactly. So because it's clear text and a lot like HTTP, if you can somehow insert yourself in a man-in-the-middle position, you can mess with this by writing a proxy and manipulate things, change where calls are going, basically turn a one-to-one call into a three-way call, send funny tones, you know, into the call. Things you can do. The difficult part is, of course, yeah. The difficult part is getting your man in the middle, which can be a little difficult, but
maybe not.
Maybe not. Yeah, especially if you're making a soft phone call from the coffee shop. So yeah, other things like here's the realm. So now I know what you're running. And SIP is still using some dark ages crypto. SIP client authentication is still using MD5, so you capture enough hashes, you can figure out what passwords are. So from an info gathering perspective, you know, scan the system with Nmap, but realize that some of the asterisk ports are not actually going to be default according to Nmap, so you have to specify a wide port range or add in some of the specific ports. And of course, I like the -O and -SV options, so you can get some fingerprinting and figure out, you know, what release of Linux it's running on.
Or attempt to try and find that out.
Yeah. And if you're scanning, especially if you're doing your SIP scanning, scan slow. Some of these systems have failed ban running, looking for, you know,
just thresholds, right? So
yeah.
Don't do it too quickly.
Yeah. So you'll just get banned. SIP vicious is like used by 99% of the world's VoIP attackers, whatever. But any script kiddie can use it, but most people don't bother to go in and change the user agent. So most manufacturers will stop taking friendly scanner as the user agent. They'll stop taking calls from that. They just, nope, I drop it. When using SIP vicious, or I guess any tool, look at using other methods. Most of them just use options. So many manufacturers are dropping the options message. So if you send an invite or a cancel, you might have more luck getting a response. And Metasploit randomizes every field. So you can't write a regex that will identify, oh, I'm getting scanned with this Metasploit module. All right, so I have a demo on this. It's on GitHub, but we want to get to the cool stuff. We do have IP tables rules that we built that will block, for a pretty decent handful of the attack tools, all the ones on Kali, except for Metasploit, or yeah, the Metasploit, and a bunch of other annoying worms and bots and stuff. So from a defense perspective, you want to probably change your user agent just to mess with people. Instead of Avaya, make it something old and obscure like Norcell maybe. Block known bad user agents, so use those IP tables rules. Newer versions of Asterisk started including this always auth reject equals yes option. What that does is if somebody tries to send you a message that's not like any register message that they send you, it'll automatically send back an error code. So you're trying to enumerate extensions and all you get back is a bunch of error codes. They're always the same and you can't figure out what the extensions are. Use fail to ban, and you know, depending on how much money you have, actually look at an external appliance like a session border controller or something that has SIP specific protection. All right, so denial of service, I guess it kind of goes without saying.
Everybody kind of knows what.
Yeah, everybody knows what a DOS is, right? The freaks, this was an interesting part for me, was like you never really hear about any freak DOS stories, because for the freaks, anything that would call attention to the fact that they were playing around with the network was like, you know, pretty much forbidden in the community. You know, nobody wants to call attention because then they're going to take our network away, and we won't have anything to play with. You know, don't break the toy. So there was some debate as to whether or not you could stack tandems, where you're basically making a call bounce back and forth between two different phone switches to tie up all of the lines, thus a DOS attack. But as the network grew, there was so much capacity, it just really didn't matter anymore. So nowadays, you know, everything's connected to the internet, especially these asterisk systems. So it's easy just to, you know, get a cheap botnet, launch a ton of fragmented UDP packets or what have you.
And overwhelm.
Yeah, overwhelm the PBX. And I spoke last year on something called telephony DOS, so you can actually make a legit phone call through a real service provider and tie up their phone lines that way. So that talk's on YouTube. So, all right, if you're going to do this, you could go with the gold standard HPing 3. Yes, you could probably write something else to do it custom made. Not very many SIP trunk providers have actually implemented TLS and TLS is used to secure SIP and RTP. Basically, I shouldn't say that. TLS is for the SIP signaling, SRTP for the audio. And many people haven't implemented it, so if you do find a system that's running TLS, you can use this THL or THCSSL DOS, the hacker's choice. And basically it just tortures the system by renegotiating the encryption parameters. And then initial and in-process method flood, so a lot of systems won't deal very well with just some random SIP OK message, like, but we don't have a call going, what is this for? And it still has to go through its machinations of what's going on, or you send it a bunch of invites.
Right, yeah, just random sequences, and it's going to, whoa, hold on a second.
Yeah.
It's going to confuse it a lot.
And then there's some like least likely things. I never really see this very much. RTP flooding, where you're just like sending a bunch of UDP at all their RTP ports, or trying to send by messages, which is very difficult, by the way, because you have to have that man in the middle position and get the long call ID and the IPs involved and all of that in order to do it. And then fuzzing or process crashing, so you get the